Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called missing number. So in this problem we have been given one array that contains the distinct numbers from 0 till n, and we need to find the missing number from this array. So let's try to understand from this whiteboard thing, right? So 3 0 1, let's say this is the array, right? And we need to find the missing number. So missing number basically 0 1 2 3. This would be from 0 till n. So which is the missing number? 2 is missing in this array, right? 2 is not there in this array, so the result should be 2. All right. Similarly, the example second, basically here if we see 0 1 2 3 4 5 6 7 8 is missing and 9 is there, so 8 will be missing. There should be 0 till n, right? All right. So, and the note section here is the your algorithm should run in the linear complexity, runtime complexity. Space complexity should be the constant space. What constant space means? Constant space means we are not allowed to take any additional storage. All right. We will jump to the additional this constant space later on. Let's go ahead and see the additional with the additional storage, right? So once we talk about the unique or the distinct item, then which data structure comes to our mind? That's what we need to think, right? So set is a data structure that we can use in this case, because that makes sure that we are having the uniqueness of the elements, right? So what we can do here, if I open another page here, let's say the first example 301, and if I am taking the set, right, and the set, what I can do, I can just add all these elements, right? 301 in the set itself, and this is in the set, and then we already have been given like 0 till n, right? This would be the 0 till n. So what we can do, we can blindly run another for loop, not another but the first for loop 0 till n, and then we can check whether these elements are there in the set or not. That's very simple, right? What we can do, 0 0 is already there, 1. So let's say if I do undo here, and then for loop 0 1 2 3. Okay, so 0 is already there, 0 is already there, 1 is already there, 2 is 2 there? No, it will say 2 is not there. Then I will go ahead and return 2, and that will be my output. So that's the very simple approach that we can use. Okay, now let's consider another case, 0 1 2. This is another test case. Okay, so this is our set. Now we will run the for loop, and the for loop will run 0 1 2 3. Why 3? Because they should be 0 till n, right? So n here is basically your length, right? Array length, that is called n, and we need to take till 3 as well, and that is the point that we need to make sure that we are covering. So 0 we will set, okay, 0 is already there, 1 is already there, 2 is already there, 3 is not there, so 3 will be our output. This will be our result. Res is the result. All right, so this is the approach. Let's go ahead and quickly code that, and then basically we will see. We will run all these two test cases first of all. So test set integer new has set, and let's store int nums set dot add num. Okay, now we will run this for loop, and we are not applying any special logic here. The problem is asking us to check these distinct number 0 till n. So we are already, this is already been given in the problem itself. We are just copying pasting from the problem, right? So this is not nothing, we are not using special logic, or we are not using superficial something. Okay, anything superficial, right? So here the thing, right, that we will understand that we need to take 0 till length, right? Not 2. We cannot take till 2 because it's the 0 till n, and that's why we need to take 0 I is less than equal to nums dot length, right? So that we can just cover this test case as well. Okay, so what we will check, if set dot if set dot contains, if set does not contains this I, that's what we are checking, right? This for loop whether this value is there in the set or not. This value is there in the set or not. If it is not there, then we will go ahead and return, right? So set, if set does not contains this value I, then go ahead and return I, and that's it. That's what we need to do. Return -1. Okay, that's very simple. Now let's check these test cases. Okay, and now this test case as well, 2, and it should return 3. Okay, and if we remove this equal sign, then it will give the incorrect answer. Why? Because we are not covering this n thing. N thing we need to cover. All right, so complexity wise it is still linear. That's what the note section is saying, that it should run in the linear runtime complexity, but the space complexity is still, we are maintaining the set, so it will still be the linear. Space complexity will also be linear, right? So that's the optimization that we need to do in the next iteration. All right, let's go ahead and try to submit, because there is no compilation error here. So this approach is working. Now let's move to the next part, how we can optimize the space complexity, right? How we can get rid of this guy set. Okay, now let's take again. So what is the example here is 301. Okay, 301. Okay, to remove this space complexity means to use the constant space, or without using any other additional data structure or storage. We need to apply some computer science fundamental or some other concept that we need to use in this problem, right? So computer science fundamentals, when we say like the another concept here, we can use the bitwise operator. So bitwise, there is another important operator is that's called XOR, that we can use it here to solve this problem. And in the Xoring, the benefit with the Xoring will be here that we don't need to maintain any additional data structure, and we can solve this. We can at least try to solve this problem. Okay, so let's see how we are going to do that. Let's first of all try to understand what XOR is there, right? So XOR is basically if the both bits are same, then basically the return will also be the 0, right? If it is 1 and 1, then if we XOR with the same bit 0 0 or 1 1, then the result would be 0, right? So this is how the XOR works. If the one bit is different, like if it is 1 0, then it will be 1, or 0 1, it will be 1, right? So this is 1, right? So 1 1 means if the both bits are same, then the result would also be 0. If the both bits are different, then the result would be 1. This is the basic of the XOR, and the same thing we will applying here, right? So let's go ahead and then again take this array 301. This is comma. Okay, 301. All right, now let's put the approach same, because it has been given 0 till n, and we already using the for loop. We are already using the for loop, so let's say 0 1 2 and then till 3. And now let's apply the Xoring here. Let me take the different color, maybe the red color. So 0 Xoring with the 3. So what I'm taking one element here and one element from here, and then Xoring with the next element 1, and the next element here with the Xoring 0, next element with the 2, and with the next element here the 1, and with the next element here with the 3. All right, so this is the Xoring. That's what I applied in the for loop, with the element in the for loop, and with this array elements as well. All right, so now let's go ahead and then just arrange these in the correct way. I mean, they are definitely in the correct way, but what I'm rearranging so that we can understand it very concisely and correctly, and then we can just apply our the same concept that we have learned earlier, right? So we have learned earlier here in the this, like if the bits are same, then the result would be 0. If the bits are different, then the result would be 1. So that's what we are trying to apply here. Now let's go ahead and do that. 1 and 1, they will be together, right? Now 2 2, there is nothing, there is no other 2, and 3 are 2 times, so let's go ahead and 3 2 times. So this guy is 0 because they both are same, right? And then 1, they both are 1. Let's go ahead and do 0 as well. 2 and then 3, they are same, so they would also become 0. So now the new uh, this is the shorter form of all this from this, right? This is the this is what we derived from this guy. So 0 and 0, they are also same. Then what we will do, we will do the 0 here, and then 2, and then 0. All right, 0 and 2. So 0 2 is non-zero, right? So 0 and 2 will become non-zero. 2, I'm just writing here, okay? 2 and then again 0. 0 and 2, 2 Xoring with 0 will become 2, and 2 will be the result. So that's how we can solve this problem without taking any additional storage. Let's go ahead and do that. So first of all, let's go ahead and get rid from this code, and let's take result. This is a question mark for now. We will just decide what the result we can take, and then let's say integer I equals to 0, I is less than nums dot length, and then I plus plus. What Xoring we were discussing here, I and then Xor with nums I, right? So remember, because we are accessing nums I here, nums I means it is the index based. So we cannot take I is less than equals to, we cannot do this, right? Otherwise, basically, because let's say if we are doing this, this will be the index out of bound, right? We cannot go out of index of the array, right? So that's why we need to do the nums I is less than nums dot length, and that's why, and that's what exactly we were doing here. But one different thing we were doing here, we were just taking 3, but we should take 0 1 2, right? So how we will get this 3? How we will get this 3? uh, you remember this question mark? We will get this 3 here. So nums dot length, and that's it, we are done. Exactly, we are done. We don't need to do anything, just return res. So if this concept is clear, Xoring, that how does it work? Like if the bit are same, if the both bits are same, the result is 0. If the both bits are different, then the result is 1. Then this question is like, it's ice on the cake, like this is nothing, right? And then just apply the same thing, 0 1 2 3. Don't get confused with this thing, right? Less than nums dot length. Let's apply simply here. And then once we are we need to get rid of this 3, because we cannot apply here. We cannot take this less than equals to, because it will be index out of bound for this nums array, right? So the nums array will be on the index based, so that's why we cannot take it here, and that's the reason we are just assigning already nums dot length, so that we can cover that case as well, right? We need to cover this guy 201, right? So that's why we are taking. Let's go ahead and quickly check what's going on here. So this 3, you see this 3, and let's say for example, if I take it as a 0, not nums dot length, right? Then what will be the result? The result will be wrong, right? It will be 2. Result expected is 3, and it is giving the output as 0, because it's not considering this case. And why it's not considering? Because nums dot length 3 we are not covering here, and if 3 is not covering, then basically it's just Xoring 0 0, and then 1 with 1, and then with 2 as well. So everything becomes 0, because everything will become same, right? And 3 is not there, so that's why we need to do the control Z in nums dot length, and we will run this code, and then it will give the correct output, right? So I hope this is clear, right? And then time complexity is same, it is still linear. TC means time complexity, SC means space complexity, and the space complexity would be order of 1, because we are not maintaining any other additional data structure or any additional storage, and that's why the space complexity is order of 1, or constant extra space, right? That's what it's saying, constant extra space complexity. So I think this is how we can do. Let's quickly very quick summary for a couple seconds before ending this video. We have been given this problem. We are the problem is saying that just take the n distinct numbers 0 till n, and we need to give this we are given this array, and we need to return the missing number. So very first thing that comes into our mind, the data structure, that which structure we can use, right? So definitely if it is a distinct numbers, we can just use the set here. So one way that we can think of here, the set, we just store all these numbers into the set, right? So where we applied in the set, so just use all these numbers in the set, and because we have been given 0 till n, so just run one for loop 0 till n, and then just um, check whether these numbers exist in the set or not. If they If any number does not exist in the set, just go ahead and return from there itself, right? That's what we were doing in the set. But the problem with this approach is the problem is asking, can we solve in this constant extra space complexity? That is the follow-up question. So then we need to think in the different manner, not from the traditional way, and we need to apply this concept here that's called the Xoring concept, right? So this is called the Xoring concept, Xor, XOR. And the Xoring concept says if the both bits are same, the result would be 0. If any bit is the different, then the result would be 1, non-zero, right? And the same concept we applied here as well. So we just run the loop simply 0 till n here, and then we just check in the array itself. We are just doing a Xoring. We are rearranging that to understand, so that we can understand. Even if you are clear like 0 or 0, this will be 0, then we don't need to rearrange, but this is just to explain the approach, that this is how it's working. That's why I rearranged that. So if this thing is clear, in the end basically 2 is coming, and this 3 we cannot cover in the problem itself, right? So we are not doing less than equals to, because we don't want to get the index out of bounds exception, right? See this in array index out of bounds exception, because it is the index based. So that's why we can take only till 2, and then how we will how we will cover this case, we will assign this in the result itself, right? Nums dot length. And that's why we need to Xor this guy as well, so that we can cover that case. Which case? 0 1 2, right? This case. So that's how it's working. Let's go ahead and quickly submit. If it works, then we are good. So this is working fine. Hopefully this is useful. Thanks a lot. Have a good one. Bye.